In Episode 7, Manage Security Within Common SDLC Methodologies, we look at how security work actually fits into the development life cycles teams already use, rather than imagining an idealized process that nobody follows. The promise is practical alignment. Whether your organization leans toward classic waterfall, iterative models, agile frameworks, or high-velocity DevOps practices, security can be woven in without constant battles or heavy-handed stalls. Instead of forcing one methodology to win, you will see how security activities and artifacts adapt to different rhythms and decision points. When you can speak this language fluently, exam scenarios about process feel much more grounded in reality. Just as importantly, you become better at guiding real teams to safer outcomes without derailing delivery. A useful starting point is the classic waterfall model, where work flows through defined stages, such as requirements, design, implementation, testing, and deployment. Security fits here by inserting clear gates and artifacts into each milestone, not as afterthoughts, but as expected deliverables. Requirement stages get security requirements and initial threat lists. Design stages produce architecture diagrams and threat models. Implementation stages incorporate secure coding practices and peer reviews. And testing stages include focused security tests and defect triage. The key is to align each security artifact with the decision being made at that stage, so it feels like part of the normal sign-off rather than an external audit. When done well, the waterfall model gives security a predictable cadence and strong documentation trail. For iterative and early-stage work, risk workshops during inception offer a powerful way to shape scope and acceptance criteria before details harden. In these sessions, you bring together product owners, architects, engineers, and security practitioners to explore threats, misuse cases, and systemic risks associated with the proposed solution. The outcome is not just a list of fears, but a prioritized set of risks that directly influence what done means for the project. Those risks can be translated into constraints, non-functional requirements, and concrete acceptance criteria that must be met before release. By anchoring these agreements early, the team has a shared understanding of what must be protected and why, which reduces friction later when trade-offs emerge. In agile settings, security becomes more effective when it is expressed as work the team can plan, track, and deliver, rather than as vague oversight. That means defining security stories that sit alongside feature stories, describing user-visible or system-visible security behaviors in understandable terms. It also means writing security acceptance tests that articulate observable conditions, such as how the system should behave under certain authentication failures, data validation rules, or logging requirements. When security stories and acceptance tests are treated as first-class citizens in the backlog, they compete transparently with other work instead of being pushed in informally. This visibility makes it easier to discuss priorities, negotiate scope, and measure progress. Security-ready definitions of done then anchor these ideas in the everyday mechanics of agile delivery. A definition of done that includes security review, key test coverage, and basic documentation ensures that stories are not considered complete until their security implications have been addressed. For example, done might require that new endpoints are authenticated appropriately, that error messages have been checked for information leakage, and that logs are emitted in the agreed format with necessary fields. These expectations should be explicit, written down, and agreed by the team, not held as unwritten rules only security specialists know. Over time, this shared checklist becomes a quiet but powerful driver of better design choices and fewer last-minute surprises. Embedding security champions within squads provides a human bridge between central security expertise and day-to-day development choices. A champion is usually an engineer with an interest in security who commits to learning, coaching, and carrying security concerns into planning discussions. They do not replace dedicated security staff, but they help interpret guidance, spot issues early, and encourage patterns that align with organizational standards. The presence of a champion makes it more likely that security questions are raised organically in stand-ups, refinement sessions, and retrospectives. As a result, security becomes part of the team's identity, rather than an external force that occasionally interrupts. In DevOps environments, pipelines themselves become a central place where security is enforced and measured. Aligning pipelines with security policies means defining how code moves from development to testing to production and what checks are required at each promotion. Secrets hygiene is a major theme here, ensuring that credentials, keys, and tokens are stored in appropriate vaults, injected securely at runtime, and rotated regularly. Promotion controls might require that certain test suites, code quality thresholds, or manual approvals are satisfied before artifacts can advance. By embedding these rules into the pipeline, you reduce reliance on ad hoc decisions and make security a repeatable part of the delivery machinery. Continuous compliance checks extend this idea by scanning for policy adherence not only during builds, but also at deployment and runtime. In the build stage, static analysis, dependency checks, and configuration linting can catch issues before they reach shared environments. During deployment, checks can validate that infrastructure definitions, container configurations, and network rules match baseline expectations. At runtime, monitoring and policy agents can enforce guardrails around configuration drift, access behavior, and data movement. Together, these checks create a feedback loop where deviations are detected quickly and corrected before they evolve into significant risks. Adapting ceremonies is another way to keep security visible without overwhelming teams. Security-focused stand-ups might be short add-ons where champions and interested team members discuss current risks, upcoming changes with security implications, or recent alerts. Backlog triage sessions can be used to prioritize security stories and tasks, grouping them into coherent slices rather than scattering them as isolated items. Post-incident learning loops that include security perspectives help teams turn painful experiences into improved designs, updated runbooks, and refined controls. The goal is to weave security into existing ceremonies with minimal disruption, not to create a parallel process that nobody has time to attend. Clear responsibility mapping across roles prevents the confusion and duplication that often leads to gaps. Developers, testers, platform engineers, product owners, and security teams each have distinct contributions to make, but those contributions must be spelled out. For example, developers may own adherence to secure coding guidelines, testers may own the execution of certain security checks, platform teams may own the integrity of infrastructure blueprints, and security specialists may own threat modeling guidance and policy interpretation. When these responsibilities are documented and revisited as methods evolve, everyone understands what is expected and who to engage when questions arise. Maintaining traceability from threats to controls across iterations and releases gives you a way to demonstrate that risks are being systematically addressed. This does not require heavy tooling. Even a simple mapping that links identified threats to specific stories, tests, configurations, or monitoring rules can be very effective. The crucial point is being able to show, for a selected threat, which measures have been implemented and where evidence of their operation can be found. In agile and DevOps settings, where changes are frequent, This traceability must be lightweight enough to keep current, but structured enough to support audits and incident analyses. Over time, it forms a living record of how the organization's risk posture evolves. Measurement is essential for understanding whether security is integrated in a way that supports rather than fights flow efficiency. Metrics such as lead time, deployment frequency, and change failure rate can be examined alongside defect density, escaped vulnerabilities, and time to remediate security issues. The goal is not to chase every number, but to ensure that quality, safety, and regulatory obligations are maintained while teams deliver at a sustainable pace. When security work is clearly visible in these metrics, leadership can see that it contributes to stability and trust, not just to compliance checklists. This alignment makes it easier to justify investments in champions, tooling, and training. A mini review at this stage helps link the adjustments you make to each methodology with the outcomes you want. You can describe how waterfall gates and artifacts keep security aligned with milestones, how agile stories and definitions of done keep security work flowing, and how DevOps pipelines and continuous checks enforce standards automatically. You can explain the champion model, the role of adapted ceremonies, and the importance of clear responsibility mapping. You can also connect traceability and measurement to leadership conversations about risk and performance. When all of these elements line up, security becomes part of how work flows, not a separate track. The conclusion for Episode 7 is intentionally concrete. Choose 2 method tweaks that fit your current environment and document them in your team's working agreements. Those tweaks might involve adjusting the definition of done, adding a simple security check to your pipeline, formalizing a champion role, or creating a short risk workshop at inception. The next action is to update those working agreements and communicate them clearly, so that your chosen changes are not just ideas, but shared commitments. As these practices take root, your ability to reason about security in different SDLC contexts strengthens, and exam scenarios about process begin to mirror patterns you see in your own work. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.